So here we are on now question number 4. I hope you are staying connected as we are practicing question after question on this topic of work, energy and power. The question is in front of you. It is a long question, not so long as well. So this is the first part of the question which is on the screen. You can pause the screen here and attempt the first part of the question. I'll just wait here for a while and now show you the second screen of the question. Not a long question if you see. So pause the screen on the second screen as well, attempt the question, come back and play the video. So while you are solving the question, as I always insist and request, please do like the videos and subscribe to the channel if you think that these videos, this channel is helping you to score well, to understand well your physics syllabus. Alright, so let us begin and understand what the question is saying. And in the meantime, when you are looking at the working of the question, please keep scoring yourself as well and see how much of a total mark you scored in this particular question. Right? So here it is. A metal ball of mass 40 grams falls vertically onto a spring as shown in this figure. So if you see what is happening, it is not so difficult to understand. The spring is supported and stands vertically. The ball has a speed of 2.8 meters per second as it makes contact with the spring. The ball is brought to rest as the spring is compressed. Show that the kinetic energy of the ball as it makes contact with the spring is 0.16 joules. Easy question, straightforward, because it is just based on the formula for the kinetic energy. What is the formula for the kinetic energy? Half mv squared. How much is the mass? Be careful, you'll have to change the grams into kilograms because kilogram is the SI unit for mass, not grams. So this thing becomes 0.04 kgs times the velocity, which is 2.8 square. Now it is time for you to take out your calculators. Work it out on your calculator. Pause the screen here for a moment and see if you're getting the same answer. See, all the things are the same, so your answer should be 0.157. 0.157. What should be the unit? Unit is not given in this question. Do not forget the unit, otherwise you lose marks. Joules. Why? Because kinetic energy is energy and the unit for energy is joules. Let us come to the second part, B part. The variation of the force F acting on the spring with the compression X of the spring is shown in this figure. Right, force versus extension or compression. The ball produces a maximum compression of XB when it comes to rest. This is the maximum compression. The spring has a spring constant, K value is also given, spring constant, which is 800 Newton per meter. Calculate the compression XB. So this is the compression that you have to calculate. From this graph, what other value can you get for this value of XB? You can calculate, you can get the value of the force for which this maximum compression is happening. From the graph, it comes out to be 14. So 14 newtons of a force is producing a compression of XB. You have to calculate XB. Spring constant is also given. So which formula do you recall that you think you can use here? It is the equation of the Hooke's law. F is equal to Kx. Right? Here the compression that we are talking about is XB. So what is XB compression? The force which is producing this compression, which is 40, divided by the spring constant, which is 800. Now it is again time for you to take out your calculator, work it out on your calculator and see if you are getting the correct answer. 0.0175. 0.0175. This should be your answer. Easy question so far. The first part was easy, second part of easy. If you are scoring 2 and 2 marks in both the question, very good. If you are not scoring full marks because it is an easy question, you should be ideally scoring full marks, then go through my theory lesson videos on these topics. Now the last part of the question. Show that not all the kinetic energy in A is converted into the elastic potential energy in the spring. So all the kinetic energy means the kinetic energy that you've calculated here. Show that this all kinetic energy is converted into elastic potential energy. How do you find the elastic potential energy? Is there any formula? The formula for the elastic potential energy is half kx square. So substitute the values. Half times 800. So what was the value of x? 0.0175 square. This will give you the elastic potential energy, the value of it. Tally it with the kinetic energy that you have calculated in the first part. Tally them. You have to tally them and you have to show them that they are not the same. There is one other way of doing this question as well. Can you figure it out? If you have done through that other way, let me know in the comment box, or otherwise you can find the other way of doing it in the mark scheme as well. If you do not understand it, let me know. We can have a discussion about it in the comment box and I can clarify it. I'm leaving it on you because it is an easy way. The second way is also very easy and straightforward and it is mentioned here. See if you understand it. If you do not, let me know in the comment box. So please do stay connected for the next question on the same topic.